Hello everyone. In this video lecture we will be discussing about scalar and vector. These are the things which we will cover in this video lecture. Basic definition of scalar and vector, equality of vector, addition of vector, in which we will study three different laws: triangle law, parallelogram law and polygon law. The fourth one is resolution of vector, dot product of vector, cross product of vector and direction of vector. So let's begin with the basic definition of scalar and vector. Scalar, the physical quantity which has only magnitude is called scalar, which means direction is absent. Or scalar can be also defined as the physical quantity which does not follow the law of vector addition. For example, current has both magnitude as well as direction, but it does not follow the law of vector addition. Current is added algebraically, therefore it is scalar quantity. This mass, speed, current, these are the examples of scalar quantity. Talking about vector, vector are those quantities which have magnitude as well as direction. The physical quantity, or simply the physical quantity which follow the law of vector addition, is called vector. For example, velocity, acceleration, force, etc. are the example of vector quantity. We denote vector by an arrow over an alphabet. An arrow over alphabet, where this is the magnitude of vector. It seems like modulus. Also, we can represent the vector by an arrow line. For example, this is a vector A whose magnitude is, let's say, small a, and it's directed in a particular direction. Another example is, this is B, whose magnitude is small b, and it has been directed in opposite direction. So in these ways we can represent a vector quantity. Equality of vectors. Two or more vectors are said to be equal if they have equal magnitude and are directed in same direction. Therefore, two vectors to be equal should have same magnitude and should have same direction. For example, let's suppose this AB is a vector whose magnitude is something 2. It can be anything. Another vector we have CD vector whose magnitude is also 2. So we can say that vector AB is equal to vector CD. Let us suppose take another example. Here this is vector AB whose magnitude is 2. Here another vector we have CD whose magnitude is 2. Here we can clearly see that the direction of the vector AB and the direction of vector CD are opposite to each other. Therefore AB is not equals to CD. Vector AB is not equals to CD. Although the magnitude of both the directions both the vectors are same, though these vectors are not equal. So a vector to be equal, two vectors to be equal, they should have equal magnitude and should be directed in the same direction. Addition of vectors. So first law is triangle law of vector addition, which states when two vectors are represented as two sides of triangle with order of magnitude and direction, then the third side of the triangle gives the sum of two vectors. So let's try to understand the vector law of triangle law of addition from this diagram. Here, suppose I started to walk from point A. First I reached point B, and then again I started to walk from point B to point C. Then ultimately I will reach point C, and again if you see that which is equivalent to the distance AC. So finally I am reaching to point C. I started from A, this is my initial point, and this is my final point. So I can reach there in two ways. First is from A to B and then B to C, and the second is directly A to C. So this is triangle law of vector addition. Here mathematically vector C is equals to vector A plus vector B. As you see, they both are directed in the same direction, or they are in adjacent direction. One, the head of this is called head, and this is tail. Let me change the color of pen. This is tail of vector AB, and this is head. Again, this is tail for vector BC, tail of BC, and this is head of vector BC. So as we see, the head of one vector is coinciding with the tail of another vector in triangle law, and from this we understand that what triangle law tries to say: when two vectors are represented as two sides of triangle, so vector AB and BC are the two sides of triangle with order of magnitude and direction. Let's not talk about magnitude, but consider direction. The direction of AB and BC are in same direction. Then the third side, which is this side of the triangle, gives the sum of two vectors in opposite direction. So this is what triangle law of vector addition tries to say. We will be deriving the resultant for triangle law of vector. So here we have a triangle OCB and another triangle OAB. I will be deriving the resultant of OA and B. I have extended this AC and CB in order to derive the expression. So now from triangle OBC, using Pythagoras theorem, we have OB square is equals to OC square plus BC square, or OB square is equals to OC. We have for OC, this is OC is equals to OA plus AC. So we have OA plus AC square plus BC square. We will let this equation as 1. Now again, in triangle A B C, cos theta is equals to AC by AB using simple trigonometry. Therefore AB cos theta is equals to AC, or simply AC is equals to Q cos theta. Here the magnitude of this AB, line AB, is Q, and we substituted the value Q in this, so we will let this equation as 2. Again, sin theta is equals to BC by AB, where therefore BC is equals to AB sin theta. This is AB sin theta. AB sin theta. Again we will substitute the value of AB, so this will become BC is equals to Q sin theta. This is equation 3. Now putting the value of AC and BC in equation first. So let's write the equation first, which is OB square is equals to OA plus AC square plus BC square. So now OB square is equals to, we have for OA we have P as magnitude, so we will substitute P plus this, we have AC is equals to Q cos theta, so we will substitute that Q cos theta square plus again Q sin theta square, and this is whole square. So now let's simplify the expression, which is P square plus 2PQ cos theta plus Q square plus Q square, sorry, this is Q cos square theta plus Q square sin square theta OP square is equals to, or OB square is equals to, let's take this Q common, then P square plus 2PQ cos theta plus Q square common, and it will become sin square theta plus cos square theta, and sin now, or OB square is equals to P square plus 2PQ cos theta plus Q square, since sin square theta plus cos square theta is equals to 1. And here we have, in this triangle OAB, this is our resultant R, this OB is our resultant. Let's recall the triangle law of addition. Here we have this as vector OA and this as vector OB, then this vector OB line must give us the resultant. So we can replace OB, or we can say OB is our resultant. Therefore R square is equals to P square plus 2PQ cos theta plus Q square, or R is equals to root under P square plus 2PQ cos theta plus Q square. So this is our resultant for triangle law of vector addition. Now let's talk about the direction of resultant. So let's see, this resultant makes angle phi with vertical. So now we have tan phi is equals to BC by OC. In this triangle we have this OC is our base and BC is the perpendicular, and as we know tan phi is equals to, which is due to equals to P by B. So, and we have already got the values of BC, which is equals to, here BC is equals to Q sin theta. So we will directly substitute that. Phi is equals to tan inverse Q sin theta by, for this OC we have OA plus AC, and OC is equals to P, so I will directly write P plus this AC is equals to cos Q cos theta, so I will write the value Q cos theta. Therefore phi is equals to tan inverse of Q sin theta by P plus Q cos theta, which is the direction of our resultant. Direction of resultant. Let's start with another law of vector addition, which is parallelogram law of vector addition, which states when two vectors are represented by the two adjacent sides of parallelogram, then the resultant is given by the diagonal passing through the sides. Now let's try to study the parallelogram law of vector addition from this diagram. This is vector A, this is vector B, and this is their resultant vector A plus B. Let's call it as R. So let's have a look on statement. When two vectors are represented by the law or by the two adjacent sides of parallelogram, so these are the adjacent sides of parallelogram, then the resultant is given by the diagonal passing through the sides, and this is the diagonal passing through the sides. Therefore this is the resultant, and The resultant of this is written by, this parallelogram law is written by r is equals to a square plus b square plus 2ab cos theta, same as the triangle law of vector. Therefore parallelogram law is equivalent to triangle law, and the direction is given by alpha is equals to tan inverse of a sin theta by a minus b cos theta, as this will become negative of this, and if you don't understand, please write down comments, I will explain it later. But this derivation is same as the derivation of triangle law of vector addition, so hope you may understand this. Now let's discuss polygon law of vector. Polygon law of vector addition states, if a number of vectors can be represented in magnitude and direction by the sides of polygon taken in same order, then the resultant is represented in magnitude and direction by the closing side of the polygon taken in opposite. So this law is valid for n number of vectors represented as polygon. Let's try to understand polygon law from this diagram. Suppose if I started walking from this point A, I reached B, then from B I started walking to C, from C I started walking to D, and from D I started walking to E, and from E I started walking and reached F. Then ultimately you can see that I am reaching from point A to F, and this is what polygon law of vector addition tries to convey. Therefore let's give it a magnitude. This is A, this is B, this is C, this is D, this is E, and this is F. So mathematically vector F is equals to vector A plus vector B plus vector C plus vector D plus vector E. This is polygon law of vector addition. Now resolution of vector. This is a very important and a concept which needs realization. Simply I have written, splitting a vector in two or more components is called resolution. So how to split and what is splitting, we will understand from a diagram. So let's try to understand resolution of vector from these diagrams. Here I have a vector A whose projection is on x-axis and on y-axis. Simply let's understand this from this diagram. Suppose I started walking from this point in the northeast direction, which is at 60 degree from the vertical line, or sorry, horizontal line. So it means I am walking some distance in the east direction and then some distance in the north direction. Ultimately I have to reach the point here. So what I will do, I will first walk from here to here, and then I will walk from this point to this point. So suppose this is our angle. Now let's name this triangle as A, B and C. So in triangle A, B and C we have cos theta is equals to B by H. So therefore, and this is our B, this AB by AC is equals to cos 60 degree. Therefore AC is equals to cos 60 degree, or sorry, AB is equals to AC cos 60 degree. And again we have BC is equals to 6 sine 60 degree, which means, so what I did here was I split it. I differentiated that for ultimately reaching this point I will walk some direction on x-axis, and then again I will start walking on y-axis, and this is what we say resolution of vector. The process of projecting a vector on respective axes is called resolution of vector and again the resultant of this vector AB and BC will be vector OC, which is A. And now for 3D or XYZ plane, if the vector A is in XYZ plane and alpha, beta, gamma are the three angles made with x, y and z axes, then the resolution is given as vector A is equals to AX or A cos alpha I plus A cos beta j plus A cos gamma k, where I, j, k are unit vector along x, y and z axes. For 2D we will split the vector generally in two components, that is x component and y component. For 3D we will split the vector in three components, x, y and z. Now dot product or scalar product of vectors. So here the dot product of two vector A and B is given by this A dot B is equals to AB cos theta, where A and B are the magnitude of vector A, B, and theta is the angle between the vectors. This is called scalar product because the product this product is scalar. It does not have any direction. The properties of dot product are, it is commutative, which means this A dot B is equals to B dot A, and distributive as well. A dot B plus C is equals to A dot B plus A dot C. Now dot product of two vectors in terms of component along coordinate axes. So let's consider two vectors, that is vector A and vector B, where vector A is equals to AXI plus BYJ plus AZK, and vector B is equals to BXI plus BYJ plus BZK. Now we have vector A dot vector B is equals to AXI plus AYJ plus AZK dot BXI plus BYJ plus BZK. Therefore AX BX I dot I plus AX BY I dot J plus AZ AX BZ is equals to I dot K again plus AY BX is I J dot I plus AY BY J dot J plus AY BZ J dot K. Again plus AZ AX I dot K plus AZ BY, this is BY K dot J plus AZ into BZ K dot K. We have I dot I is equals to 1, J dot J is equals to 1, K dot K is equals to 1, because as this is dot product and vector I, J, K are mutually perpendicular to each other, so I dot J will be 1 1 cos theta, as these are I, K are unit vectors and this theta is equals to 90 degree. Therefore Ij is equals to 0, and this implies for all I dot J, J dot K, J dot I, everything. So here this term is equals to 0, this term is equals to 0, this is also 0, this is also 0, this is also 0, this is also 0. So therefore ultimately A dot B is equals to AX BX I dot I plus AY BY J dot J plus az bz k dot k. So this is the dot product of two vectors when they are given in the forms of components. Now we will see cross product or vector product. The cross product or vector product of two vectors a and b, these are vector a and vector b, which is denoted as a cross b, is given by magnitude of a, magnitude of b, sin theta into n, where n is unit vector perpendicular to the plane containing vector a and b. Therefore, mathematically, a cross b is equals to vector a into vector b sin theta n vector, where theta is the angle between two vectors, Now suppose this is a plane which contains both vector a and vector b, then n is a vector which is perpendicular to this plane. Hence, the cross product of two parallel vector is 0. The direction of a cross b is perpendicular to both a and b. Direction of cross product is given by right hand thumb rule. Suppose this is a vector, this is vector a and this is vector b. So what we will do, we will keep our hand in this direction and fold our fingers in the direction from a to b, and the direction in which our thumb is pointing will give us the direction of the cross product. The properties of cross product are non-communicative, which means a cross b is not equals to b cross a, and a cross b is equals to minus a cross b. Distributive, a cross b, so this is the distributive law. Now, cross product of two vectors in terms of components along the coordinate axis. Suppose we have two vectors, a is equals to a1 I cap plus a2 j cap plus a3 k cap. Another vector b is equals to b1 I cap plus b2 j cap plus, this is b2 plus b3 k cap. Then a cross b is given by I j k into a1 a2 a3 b1 b2 and b3. We will find the determinant and that will be our answer. So we have discussed all the concepts of vector, and if you have any query or I have left anything, then please do write in the comment section and we will make another video for the question answer. Thank you very much.